So, good morning. So, good morning to all of you. So, today we are going to talk about the soil moisture and plant relationship. So, in previous topic, we already have discussed about the So in previous class, we already have discussed about the introduction to the irrigation engineering. What are the necessity of the irrigation engineering? What are the advantages of the irrigation engineering? And what are the techniques involved in irrigation engineering? And then different types of method also we have discussed. So in today class, we will look in detail what are the relation exist in between the soil moisture and plant. So first of all, you should understand what do you mean by soil moisture. Soil moisture means the water actually whenever there will be a rainfall or when we are applying water to a irrigation field, the water actually store in the voids of the soil. Okay, you can see in this figure. So here some voids will be there, small voids of the soil will be there. So water will be percolates or infiltrate into the soil and it will store in the voids of the soil particle, and that water will later on utilized by the plant roots for its nourishment and growth of the plant. So soil moisture is what? The water which actually held by the voids of the soil. Okay, so so actually there is the, if you take a soil sample, if you take a soil sample, in this soil sample is composed of different solid particles, different of solid particles. And if you calculate the total volume of the soil, if you calculate total volume of the soil, then that is volume of the voids plus volume of the soil solid particles. So within this volume of the voids, actually the soil moisture will be stored. Okay, and that part of the moisture which actually store above the groundwater table. So if you look, this is my plant, this is my plant, and this is my plant root, and this is my ground, this is my ground level, and this is my water groundwater table, this is my groundwater table. So above the groundwater table, whatever the moisture will be retained in the voids of the soil, that will be called as the soil moisture. Plant will not utilize this groundwater table for its growth. Plant only utilizes the moisture which will be retained in the voids of the soil particles. Okay, and the soil moisture actually depend upon the two factor. First one is called what is the water holding capacity of the soil, and this water holding capacity of the soil actually depend upon the porosity of the soil. What is the degree of porosity of the soil? That is volume of the voids to the volume of the soil. And second one is called this water holding capacity depend upon the size of the voids. First we understood about the what is soil moisture, and this soil moisture actually depend upon the how much the soil can actually retain the moisture in its voids. Okay, so what is the water holding capacity of the soil? We can better say this water holding capacity of the soil actually depend upon the porosity, degree of the porosity of the soil, and what is the size of the voids. So this size of the voids actually divided into two groups. This size of the voids divided into two groups. First one is called capillary voids, and second one is called non-capillary voids. Okay, so capillary voids, in other word, it is called as these are called as small voids. These are called as small voids, and non-capillary voids are called as large void. Another name. So this is small size of the void, and this one is called larger size of the void. So actually in capillary void, if the size will be very small, then the water will be held due to the action of the capillarity. Okay, and due to the capillarity, the water will be stored in the voids of the soil, and it cannot be drained under the action of the gravity. Okay, it cannot be drained under the action of the gravity. But in non-capillary voids, as the void size will be very large, as the void size will be very large, so what is happening? So they do not hold the water tightly, they do not hold the water tightly. Hence what will happen, larger part of the water will be drained off under the action of the gravity. So larger part of the water will be drained off due to the action of the gravity. And in capillary voids, I told you, due to the capillary action, the water is storing in the voids of the soil, so it has a very greater water holding capacity. It has a very greater water holding capacity. But as the size of the void will be very large in non capillary voids, so it induces better drainage and aeration. So better drainage and this is aeration. Okay, so the air will be circulated properly throughout the voids, and it will induces very proper drainage of the water. So if you ask me example of capillary void, that is clay. Okay, very small voids will be there. And if you ask me the non-capillary void example of a soil, that is called sand. Sand have very high voids. But we require a soil to be a mixture of clay and sandy, because we do not want the voids to be very small and we do not want the voids of the soil to be very large. We want a mixture of the small and larger voids. So for the ideal soil, if you talk about the ideal soil for irrigation or for farming, which will be better for farming, is that which nearly equal distribution of small voids and larger voids, which have an equal distribution of small voids and larger voids, such that the small void, what will it will do, small voids will provide adequate water holding capacity. Okay, it can retain the water for longer period of the time. But for large void, what will happen, it provides better aeration and easy extraction of the water by the plant roots. Okay, the air will be circulated properly through the voids, and the plant root will extract the water is very easily. It cannot apply much more stress to extract the water. So for ideal soil for farming or gardening is that mixture of the capillary voids and non-capillary voids, that is called loam soil. Okay, that is called loam soil, or that is another name is called garden soil. So it is the mixture of sand and clay. It is the mixture of sandy soil and clay soil. So now water, how the water will be stored in the voids of the soil. So water in the voids of the soil can be divided into three parts. Actually, can it is divided into three parts. So first one is called gravitational water. Okay, first one is called gravitational water. So as the name itself saying, this is called gravitational water. So this part of the water will not be utilized by the plant root, rather than it will be drained off due to the force of the gravity. Okay, so it is not held by the soil. It's immediately, or we can say 1 to 3 days, it will be drained off due to the action of the gravity, and finally it will join with the groundwater table. Okay, so if you understand this thing by a figure, by drawing a figure. Okay, let me yes. So if this will be our irrigation field, okay, this is our irrigation field, and this is my plant roots, this is my plant roots. Okay, and here somewhere there will be your groundwater table. This is my groundwater table. So if you apply the irrigation water to the field, if you applying the irrigation water to the field having some discharge, then what will happen, some depth of water will be retained on the irrigation field, some depth of the water will be retained on the irrigation fields. Okay, so this is the depth of the water will be retained on the irrigation field. So in this consequence, if this water will, what will happen within 1 to 3 days, within 1 to 3 days it will be trained due to the action of the gravity, okay, through the voids of the soil, and it will train due to the action of the gravity, and finally it will join with the groundwater table. Finally it will join with the groundwater table. So if this water will be detained for a longer period of the time, then what will happen? It prevents the air circulation process for the plant growth. Then it will harmful for the growth of the plant. So this gravitational water should be drained as quickly as possible. It should not be detained for longer period of the time. That's why it is written in the first. So it is that water which is not held by the soil, but it is drained out under the action of the gravity. Okay, so it is how many period of time it will be remain in the soil? It is remain for a very short period of the time. Generally it is retained for 1 to 3 days. So if it will be retained for a longer period of the time, then what will happen? It prevents circulation of the air in the soil, and it is harmful to the crops if present for longer duration. Okay, so we do not want the gravitational water to be retained for longer period of the time. Second types of the water. Okay, second type of the water, that is called capillary water. This is called capillary water. So capillary water is what will happen. Let's understand this point. So capillary water is that part of the water which actually retained by the soil. Where it will be retained? Obviously, it will retain in the voids of the soil. If this is my ground level, okay, this is my ground surface, and here this is my plant, okay, this is my plant, and we are applying some amount of water for the irrigation purpose. Okay, so there will be some water will be detained for some period of the time, and I told you it will what will happen? It will percolates, or it will infiltrate to satisfy the soil moisture deficiency. And if it is gravitational water, then it will be joined with the groundwater table within 1 to 3 days, within 1 to 3 days. So during its movement from this point to this point, some part of the water will be stored in the voids of the soil. Some part of the water will be stored in the voids of the soil due to the surface tension, due to the surface tension property. Okay, and that part of the water which will be stored in the voids of the soil, and it will be utilized by the plant roots, that part of the water is called as capillary water. So it is that part of the water which is retained in the soil after gravity water is drained off, after drained off. And this is the part of the water which actually absorbed by the plant roots, which actually absorbed by the plant roots. Means plant utilize this part of the water for its nourishment and growth. Okay, so this water held in the soil by, I told you which section of force, by surface tension between the soil particles. Okay, and plant root gradually absorb capillary water, and the plant root actually gradually it absorb this capillary water. Hence, it is the main source. It is the main source of water for the plant growth. And there is another name for this capillary water, therefore it is also called as available water for the plant growth. So which one is available water for the growth of the plant? That is called capillary water. So next, third is called as, this one is called as hygroscopic water. Third one is called as hygroscopic water. So hygroscopic water is that water which is absorbed by the soil particles from the atmosphere, from the atmosphere. from the atmosphere. Means if you take a soil sample, if you take a soil sample and you keep it for some period of the time in atmosphere, then it will absorb some part of the moisture, and that moisture which will be absorbed by the soil from the atmosphere, and it will have a very high adhesive force. It will very high adhesive force, so we can say it will held with the soil particles so tightly the plant root cannot utilize this water for this growth and nourishment. Okay, so it is held very tightly by the soil particles, therefore it cannot, it cannot be extracted by the plant roots. So hygroscopic water also cannot be used by the plant. Gravitational water also cannot be utilized plant. Only the part of the water which is utilized by the plant is called as capillary water. So this is the part is called which is called as available water. Okay, this is called available water for the growth of the plant. Now we will talk about this is soil moisture tension and soil moisture stress. Soil moisture tension and soil moisture stress. So, soil moisture tension means what? Soil moisture tension means the amount of force is exerted by a plant root per unit area to extract the moisture from the soil is called as soil moisture tension. So, if there is a plant, suppose this is my plant, okay, and this is my ground, and this is the root of the plant. So definitely the moisture will be retained in the voids of the plant. This is the moisture will be retained in the voids of the plant. So this, if the moisture capacity will be less in the voids, definitely the plant has to apply more tension or more force to extract the water from the voids of the soil. If the moisture will be present plentifully in the voids of the soil, definitely the plant has to apply less force to extract the moisture from the voids. So that is called, if the moisture content will be very less in the voids, then the plant root has to apply much more force per unit area to extract the water for its growth. This is called soil moisture tension. Okay, so if the moisture content will be more, if so, what I told, the soil moisture stress is inversely proportional to the moisture content. So if the moisture content will be more, definitely the soil moisture tension will be less. Means soil moisture tension is the force exerted by the force per unit area exerted by the plant root to extract the moisture from the soil. Okay, so we always keep in mind the moisture content in the voids should not be fall below a certain limit. Otherwise, what will happen? The plant has to apply much more force to extract the moisture from the soil. Okay, so the for the plant proper growth of the plant, optimum growth of the plant, the soil moisture stress we have to keep as minimum as possible. Okay, for that we should not increase the moisture content to a saturation above the saturation capacity. Otherwise, there will be plant will be wilted. So there is certain limit up to which we can apply irrigation, at what interval we should apply irrigation, such that there will be optimum growth of the plant or crops will happen. Okay, so there is a limit. We should not apply the water as we can. There is a proper limit, at proper interval time we should apply. So this is the next point. For a given soil, okay, for a given soil, soil moisture stress is inversely proportional to moisture content. And you always remember this soil moisture stress, a soil moisture tension is always expressed in the form of unit will be atmosphere. Okay, so if zero atmosphere means soil moisture tension will be less, means the plant root is applying less force per unit area to extract the moisture. If the soil moisture will be 32 atmosphere, it means what? The plant root exerting much force per unit area to extract the water from the soil. Okay, means there is a deficiency in water in the soil. We start irrigating the field. Okay, so if you know the soil moisture tension, we can predict the moisture content in the soil. If we know the moisture content in the soil, we can also have the idea regarding soil moisture tension. Okay, so if this is the third point is written, if we know soil moisture tension at various moisture content, then we can determine how much water is available for plant and what amount of water must be added to the soil to remove the soil moisture deficiency. Okay, that is we can have an idea. So now there is called soil moisture stress. So soil moisture stress is nothing but this is soil moisture tension plus this is osmotic pressure. So osmotic pressure is what? Suppose there will be any salt content present in the soil. Okay, and there is soil. Okay, there is soil, and if there is some salt content will present after we are irrigating the field, after we are irrigating or we are supplying the water to the field, then what will happen? This soil will now it will become alkaline soil. Now the soil solution will become alkaline soil solution. Okay, so what will happen? This salt will actually now will go to the voids of the soil and it will obstruct or it will clog all the voids. So now again the plant has to apply much more force per unit area to extract the moisture from the voids, because all the voids will be now occupied by the salt particles, occupied by the salt particle. Now the root of the plant has to apply much more force per unit area. So so for better growth of the plant, this osmotic pressure also should be keep as minimum as possible, so that the soil moisture stress will be less. Okay, if the soil moisture stress will be more, then obviously the plant is not growing properly. There is a not optimum growth of the plant is not happening. Okay, so soil moisture tension at field capacity will be range from 1/10 of atmosphere to third of atmosphere. That we'll discuss in next. Now we'll discuss about the soil moisture content, or this is called soil moisture constant. Okay, so I told you this is the soil particle, this is my soil particle. So if you keep the soil particle some period of the time in the atmosphere, so it will extract or it will absorb some amount of moisture from the atmosphere. So that part of the water which will be absorbed by the soil from the atmosphere and it held so tightly with the soil particle that the plant root cannot utilize this water for its growth is called as hygroscopic water. Okay, and above that the moisture will be stored in the voids of the soil. Okay, so the part of the soil which will be retained due to the surface tension between the uh, water particle, and it will stored in the voids of the soil, and this is called as available water, because the plant root utilize this part of the water is called as capillary water. Above that, if some water will be retained above the capillary water, that will called as gravitational water. So water stored in the soil in three parts. Water stored in the soil in three parts. This the top limit, the maximum limit of the gravitational water is called as saturation capacity. Saturation capacity means all the voids of the soil will be saturated. All the voids of the soil will be saturated. Then the lowest limit of the gravitational water, or we can say that upper limit, lower limit of the gravitational water, or upper limit of the capillary water, that is called field capacity. Field capacity means this is the minimum amount of moisture content. This is the minimum, obviously minimum. So minimum amount of moisture content which actually retained in the voids of the soil and which cannot be drained due to the action of the gravity force. That is called field capacity, or this is the maximum amount of moisture which will be retained in the voids of the soil which cannot be drained by the action of the gravity. That is called field capacity, and this is the factor of safety, optimum moisture content. And this part of the water, this depth of the water is called readily available moisture. Means this is the part of the water which the plant can easily extract. The plant has not applied much more soil moisture stress to utilize this water for this growth. And this total depth is called as available moisture content. Okay, now you tell me, if the soil saturation capacity mean moisture content will be very high, obviously the soil moisture tension will be very less. I told you this is inversely proportional. So field capacity, there is little less than saturation capacity, so here it is increases, so soil moisture tension is 1/10 to 1/3 atmosphere. And here permanent wilting point means if the moisture content will go below this line, then the plant will be wilted, the plant will die. So here the soil moisture tension will be more because the plant has to apply much more force per unit area to extract the moisture. Okay, so always we are taking a factor of safety. So what we do, if the moisture content will fall up to the optimum moisture content, then we are actually start irrigating to restore the moisture content in the void. And it is depleted gradually, again we should apply the irrigation, we do the irrigation to restore the moisture amount in the voids of the soil, so there will be optimum growth of the plant will happen, the plant should not die. Okay, so this is the way how actually the moisture will be stored in the voids. Actually the moisture will be stored in the voids in three parts. First one is gravitational, capillary water and hygroscopic water. Okay, so saturation capacity, I already told you, saturation capacity is what? It is defined as the total water content of the soil when all the voids of the soil are filled with water. Okay, so this is called saturation capacity. So this is also called maximum water holding capacity. Maximum water will be stored in the void, so full everything will be saturated and the excess amount of water also there. So at saturation capacity soil moisture tension will be zero, obviously, because soil moisture tension will inversely proportional to moisture content. If it is completely full, then obviously it will be less. So there is practically this is zero atmosphere we are taking. Field capacity is what? It is the maximum. Why it is called maximum? Later on it called minimum, because it is maximum. Because this is field capacity. This is the upper limit. This is the upper limit and this will be lower limit. So this is the maximum. This is maximum and this is minimum. This level is minimum. So this is the maximum amount of moisture will be stored in the voids. Okay, maximum amount of moisture will be stored in the void, and that will not be drained, due to the gravity force, because this is the zone of the water which will be stored in the voids of the soil due to the surface tension, and it is utilized by the plant root. Okay, so it is utilized by the plant root. So this is the depth of the water and this is the maximum top level. So that's why this is called maximum amount of moisture. Okay, when all the voids will be full of moisture. Okay, so this is called, that's why it is called, it's a maximum water. You just remember this is maximum water which can be held by soil against gravity force and depends upon the porosity and capillarity. Moisture content at field capacity includes hygroscopic water and capillary water. Obviously, so if you talk about the field capacity, it includes both because this is the capillary water zone and this is hygroscopic water. So it includes both hygroscopic water and capillary water. Irrigation water has to supply to the crops when the moisture content below wilting point. Obviously, if it will fall below wilting point, then one has to apply the water to increase the moisture content in the voids of the soil. So field capacity is what? We know from the, that is water content will be from geotechnical engineering, weight of water to the weight of solid particles. Similarly, field capacity is weight of water retained in certain volume of the soil to the weight of same dry volume of the soil. Okay, same the dry volume of the soil. Permanent wilting point. Permanent wilting point I told you. So this is the permanent wilting point. So if you better I should again draw the here. So this is the, I told you this is my soil, the dry soil. Above the soil this is my called, this is the soil, and this is called hygroscopic water. Above hygroscopic water this is called capillary water, and above capillary water this is my called gravitational water. Okay, so this limit is called as permanent wilting point. Okay, sorry, this is, so this is the limit. So this is the limit is called permanent wilting point, and this top limit is called field capacity, and this is called saturation capacity. Okay, let me draw again here. So this is my soil sample, dry soil. This is my dry soil. Above that soil, this is my hygroscopic water, and above this is my called as capillary water, and above this is my called as gravitational water. Okay, so the lower limit of the capillary water is called as permanent wilting point, and upper limit of the capillary water is called as field capacity, and this is called saturation capacity. Okay, so permanent wilting point is the minimum water content which is present in the void. Minimum. This is the minimum, and if the moisture content will fall below this permanent wilting point, then it will be difficult. It will be dangerous for the growth of the plant. So you always remember, whenever the moisture content will fall below optimum moisture content, then we'll do the irrigation. But practically, theoretically, if the moisture content will fall below permanent wilting point, then we start irrigating. But for a factor of safety, we are taking up for the optimum growth of the plant, the moisture content should not fall below optimum moisture content level. So wilting point is the moisture content, minimum moisture content we can better say, below which plant can no longer extract moisture from the soil, cannot longer extract moisture from the soil. So at this moisture content, plant leaves will be wilted. Plant leaves will be become dry, and finally plant will wilted. So permanent wilting point depends upon nature of the soil. Okay. So permanent wilting point is the lower limit of the capillary water and upper limit of the hygroscopic water. Now available moisture I told you. So this depth of the water which is called it available moisture for the growth of the plant, and this is also called maximum storage of the soil. Readily available moisture I told you, this depth of the water which is ready, the plant can easily extract this moisture for this growth of the plant, that is called readily available moisture. Means 70 to 80% of the water will be easily utilized by the growth of the plant. Means once the moisture content will fall below the optimum moisture content, then one should apply irrigation. One should do the irrigation to the field. Okay, so practically it is taken 75% of the available moisture content. Okay, readily available moisture content will be 75% of the available moisture content. So in next class we'll talk about the depth of the water held in root zone. What is the depth of the water will be held in the root zone? So in today class we discussed about the soil moisture plant relationship, and next class we will talk about this thing in detail. So I hope you enjoy this class today, and please subscribe and like this channel. So this is officially channel. Thank you. This is officially thank you channel. So thank you. So have a good day. Thank you all.